This is the first videos for chapter 14.2 Applications in Business and Economics. So the first topic we have here is continuous income stream. So we started with a simple example having an obvious solution, and later on we will generalize the concept to example having less obvious solutions. The first question says, suppose that an aunt of yours have established a trust that pays you $2,000 a year for 10 years. What is the total amount you will receive from the trust by the end of 10 years? Since there are 10 payments of $2,000, right? So we have 10 payments of $2,000 each. So totally you should receive 10 times 2,000, right? So obviously that would be $20,000 total, right? So that's easy to figure out. And we now try to look at the same problem from a different point of view. So let's assume that the income stream is continuous at the rate of $2,000 per year. So we're looking at this as the rate. $2,000 per year. If you look at the picture, I know it's not very clear, but I will provide you with this file online. This is showing as time goes, your income is still maintained in a constant level, which is $2,000 per payment per year, right? Okay, so we are looking at the area under the graph of f of t, the function of t equal to 2,000 from 0 to t represent the income accumulate t years after its start. So for example, if it's 1/4 years, the income would be 1/4 of $2,000, which is $500. When t is 1/2 of a year, the income would be half times 2,000, which is $1,000. For t equal to 1 year, the income would be 1 times 2,000, which is $2,000. And for 5.3 years, then the income would be 5.3 times 2,000, which is $10,600. And when t equal to 10, then the income would be 10 times 2,000 equal to $20,000. So the total income over 10 years period, that is the area under the graph of f of t equal to 2,000 from 0 to 10, is also given by the definite integral. So that's what we have been doing, right? So we can use the definite integral from year 0 to year 10, and then we take the integral of 2,000 dt because it's over time, right? So when we take an integral of that, then this will become 2,000 t, and your t limit is from 0 year to 10 years, right? So we can plug in 2,000 times the upper limit and then minus 2,000 times the lower limit. Oops. There you go. Okay, so that would still be $20,000. So that's another way to calculate that. I know it's not intuitively clear to you why we would do that, but it would have other application for question that's coming up. So we just want to let you know that work, and that's one way to look at it. Let's look at the second example. So the second example is continued income streams. The rate of change of the income produced by a vending machine is given by this. So a lot of this problem is like not for personal kind of question, but looking in the perspective of a business. If they calculate like maybe in the future how much income they're gonna have, like including the capital and reinvestment of the company, etc. So this time we're looking at the vending machine, and t is time in years since the installation of the machine, and the total income produced by the machine we need to find for the first 5 years of operations. So we're gonna say the total income is going to be taking an integral from 0 year to 5 years, and then we're going to have this function e 0.04t dt. Alright, so let's see. We're going to have we can pull out the 5,000, right? So let's do that first. Equal to 5,000, 0 to 5, e 0.04t dt. So when you take integral of that, because the exponents look like a function, so you're going to need to use substitution for that part. So I'm going to get a little bit bigger piece of paper so I have some room to work for that. So we got 5,000. This is starting from 0 to 5. E look like I'm going to need to let u equal to 0.04 t, so du is going to be 0.04 dt, right? And I don't have 0.04 as my coefficient, so I'm going to need to divide both sides by 0.04, 0.04. Alright, so 1 over 0.04 du will equal to dt. Alright, so I'm going to need to use that, but because this is a definite integral, so we're going to need to also find the new u limit, right? Okay, let's see. So we got x equal to 5, I'm sorry, not x, but t equal to 5, and t equal to 0, and u equal to 0.04 t, right? And u equal to 0.04 t. So one you need to plug in 5, one you need to plug in 0. The top one would be 0.20, right? And the bottom one would be just 0. So those are my new limits. Alright, so here I can say my 0.04 t is my u, and my dt is going to be 1 over 0.04 du. Okay, no, it's a mess. Let's try. So I can pull out the coefficient out there, so this becomes 5,000 over 0.04, and then take integral eu du, right? So that one is not too bad because we can figure that part out. That is going to be 125,000, right? And then to take that, it would be e of the u, and that's it, right? Plug in the new limits, which is 0.2, and this is 0, right? 0.2 and 0, got it. Okay, so now 125,000, we're gonna need to plug in those. So one is e of 0.2 subtracting e raised to 0, right? E raised to 0 is 1, so 125,000 of e to the 0.2 minus 1, so that would be about 152675.35 minus 125,000. So together we will get about 27,675 and 35 cents. So depending on if they want the cents, that would be it. If they want it to be a whole number, that would be that. So this is trying to find the total income after you install the vending machines from 0 to 5 years. Alright, so that's the first example. Okay, this is the next example, and we are looking at the definition of total income for continuous income stream. So again, we are using the integral methods, looking at the area under the curve. So the total income is from A to B, taking integral of the function. Alright, so let's look at this. Starting at age 30, you deposit $2,000 a year into your retirement account, IRA. Treat the yearly deposit into the account as a continuous income stream. So that's how they want you to handle it. If the money in the account earns 6% compounded continuously, how much will be in the account 35 years later? When will your retirement, when you're retired at age of 65, how much of the final amount is interest? So because it's continue compounding, so we're going to treat this with the A equal to PERT. So we got $2,000 E 0.06 for the interest, and then times T is going to become our function. So the continuous compounding interest functions, and that's our function. And they mention starting at age 30, right? So age 30 equal to year 0, and then you stop at age 65. So 65 subtracting 30 will give us 35, right? So that would be the upper limit. So lower limit and upper limit. Okay, so now let's see. We are ready to do the continue total income thing, right? So how much is the final amount interest and how much will be in the account? So total income is going to be taking the integral from year 0 to year 35, and then my function is 2000 E 0.06 t dt. So some of you know how to take this like with the shortcuts. I'm going to just keep doing the substitution because that's how we introduce to you. So I can move the 2000 out because it's a constant. So here, let's see, we have 2000 and we got 0 to 35 E 0.06 t dt. So I'm going to let u equal to 0.06 t and du would be 0.06 dt. I don't have 0.06 here, so both sides divided by 0.06. So 1 over 0.06 du equal to dt, right? So I'm going to need this, and because it's definite integral, I also need to find the new u limits, right? Okay, so I have my t equal to 35 years and t equal to 0, and use my u function. Here it's supposed to be 0.06 times my t. 0.06 times my t. So one is 0. The other one is what? Times 35 is 2.1. So those are my new limits. Okay, so plug it in. We got 2000 0 to 35. Oopsie. E raised to u, and then 1 over 0.06 du, and the coefficient go outside, so 2000 divided by 0.06. I guess we are ready to take the integral. So we got e of the u and then plug in, instead of 0 and 35, my new limit. So that's a common mistake, people forgot to put in the new limits. This is 0 to 2.1, right? So we got 2000 over 0.06. I would suggest you just plug the whole thing into the calculator, because otherwise it would be a little bit off. Minus e to the 0, which is 1, right? So if you can plug this to the calculator, and you can find the final answer. So let me see. I'm gonna have 2000 divided by 0.06, and then I can hit enter first, times parenthesis, find my e, which is on top of ln, right? Raised to 2.1, and then move the arrow down. You're subtracting 1 here, right? Close the parenthesis like that. So your answer should be 238,872.33. So that looked like correct. I'm going to write that down. So it'll be 238,872.33. So that is the total amount you have in the account after 35 years, right? So in account, when your age is 65. Alright, so they also want to find the interest, right? So how do we find the interest? Total interest. You are going to have to use the money in the account, subtracting on how much money you put in, right? So we just found the money in the account is 238,872.33. Subtracting, you were putting in 2,000 each year for 35 years, right? So let's see. I have some space I can put in here. Okay, so this number need to subtract 2,000 times 35. So you make a lot of interest, $168,872.33. So this is the amount of interest you made over 35 years if you can find a deal that's 6% compounded continuously. So that's your total interest. Sounds like a really good deal. Alright, so that's this one.